Hello and welcome back to my channel. As you all know, we are doing the problem series, and in this series we have already completed 6 problems, and our current topic is based on organic chemistry, carbocations and carbanions. I am dealing with the stability of carbocations, carbanions, and in this context we take resonance into account, we take aromaticity into account, and a few features like inductive effect. Now let us try to see what is our current problem, and then we'll explain it. As you can see, students, we have a compound on your screen. In this compound, I have mentioned 4 hydrogens as Ha, Hb, Hc and Hd. What you have to tell is decreasing order of their acidities. You have to put first which is most acidic, then in this order you have to go the bottom. Now what you have to do, you have to pull the hydrogen. For an example, if I talk about the hydrogen number A, you have to pull this hydrogen as H plus. Mind you, I am talking about their acidity, so it should be removed as H plus. Once you remove this hydrogen as H plus, this electron remains with this carbon from which the hydrogen was attached, and as the bonding electrons come on the carbon, you will get a carbene ion. Okay, so from this question, this diagram, what you have to do one by one removal of proton. First you have to remove the hydrogen number A, then B, then C, then D, one at a time, one by one. And as you will do, as you remove H plus, the carbon from where the hydrogen is attached will get a negative charge and you will see a carbene ion. Now when I say about the acidity of that particular hydrogen, I mean that the tendency with which that hydrogen will be given out as H plus, and this tendency is going to be higher if the formation of carbene ion after removal of proton has happened. The carbene ion forms. If that carbene ion is stable, then the proton removes easily. It becomes easier to get that proton out because the outcome is stable. The outcome is carbene ion. You have to see the stability of carbene ion, and if at all it is stable, with that ease the hydrogen will be given out as proton. So you have to basically make the carbene ion, and will have to judge the stability of the 4 carbene ions which will be generated by removing A, B, C and D one at a time. So I will start with A and will proceed like that. So first of all, I will remove the proton A, and as you can see on your screen, I have released this proton which was attached at position A, and a carbene ion character has been created. The carbon has got the minus charge now. Now I have to assess the stability of this carbene ion. More the stability, higher will be the tendency that the proton is removed as H plus. The hydrogen is removed as H plus. So once you see this negative charge, I have already spoken a lot about the charges, that the charges are not a good thing. If a plus charge comes or a minus charge comes, you have to think about the delocalization of that charge. Why I am saying this? Because if it remains localized, it's a huge burden. It's a huge crisis. And if anyhow this crisis is diluted by dispersal of the charge, by distribution of the charge, by sharing of that charge through any effect like inductive or resonance effect prominently, then it gets stability. So in order to find whether there is a possibility, let us try to understand, let us try to find conjugation. You see negative charge, single bond, double bond, and as soon as you find this, you are optimistic that there is a delocalization of charge. And how to do that? You shift this negative charge like this, one position ahead, the lone pair will float and it will make a pi bond. So I made the structure from here first to here. Okay, so a pi bond will come. As you can see, a pi bond has been created, and simultaneously these pi electrons will sit on this carbon, and this carbon, as you can see, this carbon will gain the 2 electrons and a lone pair will be now sitting on this carbon, and a negative formal charge comes. The carbon which gets the electron gets the negative charge, and from this carbon the negative charge goes away. Why? Because the electrons are going away from this carbon. A plus will come and plus minus becomes 0. So you can easily see this particular carbon has 0 formal charge. Okay, now as you see this negative charge, and you try to see whether there is other possibilities also. Yes, other possibilities are also present, like minus, single, double. So you move these electron one position like this, and simultaneously these pi electrons are going to sit on the carbon, this carbon, and you can easily see the carbon which gets the electron gets the negative charge, and from where the negative charge, from where the electron goes away, gets the positive charge. Earlier it had the negative charge, it will get a positive charge, and plus and minus becomes 0. So you have created the structure number 3. So you are basically witnessing that the negative charge is delocalizing. It is getting shared amongst different carbons. By what means? By the means of resonance effect. And finally you see this negative charge is again in conjugation. How? Minus, single, double. So you can go one resonance structure ahead. So you can delocalize these electrons like this, and the pi will sit on this particular carbon. So as it goes away, this carbon gets the plus charge, plus minus becomes 0. As these 2 electrons spreads, it makes a new double bond, and simultaneously as these 2 electrons sits on this carbon gets a lone pair and it gets electrons, so minus formal charge also comes. So these are the 4 resonating structures. You mind you, these are the 4 resonating structures which are associated with the dispersal of negative charge, the sharing of negative charge, the delocalization of negative charge. So you have to remain concerned with these structures only, because you are concerned about the stability of carbene ion, which involves the delocalization of charge. So 4 structures are helping to stabilize this negative charge. Okay, let us try to understand what happens with B. As you understand, now you know that we had the B here with this carbon, so that proton, that hydrogen I have removed as H plus, and the electrons are now sitting on this carbon and a carbene ion is created. Now you have to see the stability of this carbene ion. You have to see whether this carbene ion is stabilized through resonance or not. So once you see this, you find yes, there is a possibility. How? Negative charge, single bond and double bond. Once again, negative charge, single bond, double bond. So what do? You spread it like this, and these pi electron now sits on this carbon. So as you do this, a double bond character, so I have made this was structure number 1 and this is structure number 2. So a double bond character will come because of the spreading of, because of the delocalization of lone pair as a pi electrons, and as these electrons sits over this carbon, it gets a lone pair and the negative formal charge. So After this, you think about what next. Is there any other possibility left? Yes. How? You see, there is a negative charge, single bond and a double bond. So again there is a possibility. So let us try to see that possibility also. For that, these two electrons will float like this to make a new double bond, and from this carbon the electrons are going away. It will get a positive charge. Earlier it had minus charge, plus and minus will become zero formal charge. Okay, and a new pi bond, yes, it has developed, and simultaneously these pi electron will go to the oxygen, and as it shifts to oxygen, oxygen gets a negative formal charge. So you have seen that the removal of the hydrogen number B creates a carbene ion, and that carbene ion is again stabilized by the help of resonance effect, and the three structures you have drawn are directly related to. You have to draw those structure which solves your purpose. What was your purpose? Your purpose was to show that this negative charge can be delocalized. It can be spread. So you have drawn the three possible structures. Okay. Now coming on to the hydrogen number C. So if you remember, you had the hydrogen number C at this position, and from here you have removed, and the bonding electrons, they sit on this carbon as a lone pair, and a negative formal charge comes, and a carbene ion it is called as. Now you see that you have to stabilize this carbene ion. Now what is the possibility? Then you search about the possibility, then something comes in your mind. Is there resonance? Is there any conjugation? Let us try to see. You understand, this is a negative charge, negative, multiple, double, single. If you try to see the conjugation left side, negative, double, single. Now this is not the situation of conjugation. You have to have negative, single, double. Negative, single, double. You don't have the situation like negative, double, single for the conjugation. The next thing is, if you see the right hand side, again negative, single, single. So either you go left or you go right. Both sides there is no possibility of resonance, delocalization of this negative charge, and because of that the negative charge stays at that carbon and it is localized. Now you have a situation where earlier you saw that in the case of A, in the case of B, there were resonating structures. The negative charge was delocalizing from one carbon to another carbon, and it was good for the health of the carbene ion. But here it remains localized because of lack of conjugation. Now one thing more I want to say, that this is a carbon which is now if you try to see the steric number, what is the steric number? I have already told several times in my previous videos. This helps in finding the hybridization. And how to calculate the steric number? You have to sum all the sigma bonds plus lone pairs, Now if you sum all the sigma and lone pair associated with this carbon, so you understand one sigma here, and one lone pair. So if you count these two things, 2 plus 1, it comes as 3. If the steric number remains 4, it is sp3 hybridized. If the steric number remains 3, like in present case, the hybridization becomes sp2. So you understand it is an sp2 carbon, and sp2 carbon has this negative charge. Why I am saying this, because you might come to a situation where you have to compare the two carbene ions. One carbon sp3 hybridized. For an example, if you had a situation like this, CH2 negative charge CH3. Now if this is ethyl carbene ion, if you find this situation, you have sigma bond here, sigma bond here and a lone pair. If you see the steric number, again you have to count all the sigma bonds and the lone pair. So 3 sigma and 1 lone pair, it comes as 4. So hybridization is sp3. Now what is the difference between the carbene ion being sp3 and the carbene ion being sp2? Yeah, there is a difference. The S character in sp2 hybridized carbon, here the S character is 33 1/3%. And if you see here, the S character is 25%. You understand the electronegativity of any element, of any atom. It also depends on the hybridization. Although in both the cases the element is same, carbon, but its hybridized state is going to change their electronegativities. The one which has higher S character has more electronegativity in comparison to the one which has a lower S character. So the carbene ion, where the carbon is sp2 hybridized, is a more electronegative carbon. And you understand, you know, any atom which is more electronegative will relish the negative charge more, will enjoy the negative charge more, is more capable of holding the minus charge. So sp2 carbene ion is stabler than sp3 carbene ion in that sense. Okay, so okay, if it comes, you should deal it like that. Now C is just a matter of localized situation where the resonance is not a possibility, but still one relief is there, that the hybridization state has more S character. That is a sign of relief. Coming on to D now. If you see the D, here you had the D with you, and I have given out that hydrogen as H plus, and this carbon from where it was attached gets the carbene ion character. Now if you see this negative charge and try to see if there is any possibility of conjugation, resonance, delocalization, yes, you have the possibility. How? Minus, single, double. So you have to just spread these two electrons to make a new pi bond, and from here, from this carbon, the electrons are going away. It will get a plus charge, but earlier it had minus charge. Plus minus becomes 0. So you understand the formal charge is 0, and it spreads, so a pi bond comes, and simultaneously these pi electron will sit on this carbon, and this particular carbon, as you can see, has acquired a lone pair and a negative charge. So from the resonance you have got this. Now you understand, is there any other possibility left? Yes. How? Negative charge, single bond, double bond. So you can spread these electrons to make a new pi bond, and simultaneously these pi electron will sit on this oxygen, and a minus charge will come on this oxygen. Okay. Once you have done this, you are thrilled to see a benzene ring in the resonating structures, and you see this is what I am talking about. A benzene ring has came. And what is the goodness of benzene ring? I have already told you in my last video. If you have left that, if you have missed that, you should watch that video completely. The benzene ring is a symptom of stability. It is aromatic in character. So aromatic behavior is now appearing in this carbene ion, and aromaticity is it makes you stabilist. If for an example, why I am saying stabilist, in any question, if you find that one of the option is making the things aromatic, rest options are not making the things aromatic, they are just in general, then you should give preference to the one which has got aromatic character. In that sense, I am saying stabilist. So all the 4 hydrogens you removed one by one, but only the last, that is the D1, once you got removed, you found that an aromatic character is given to that carbene ion, and it makes it far ahead. It makes it far stable in comparison to others. Is it okay? So that is the point you should always be looking once you are solving any question. So after looking at all the removal of hydrogens A, B, C and D, I have made a comparison. I have given, now you see what I have given. I have written all the stablest resonating structures. I have written all the stablest resonating structures of all the 4 carbene ion we got in the process A, B, C and D. And this is what you are going to compare. From the 4 carbene ions, you have to compare their king structures, their stablest structure, and from there you have to put a hierarchy, which is the most stable carbene ion, that will give the H most easily. Okay, that will be most acidic in nature in that way. So once you analyze, you have already deciphered, you have already focused one thing, that out of 4 options, out of 4 figures I have given, only the D figure is having a benzene ring character. So being this a benzene ring and aromatic in character, you have to put D in the driving seat. This is going to be the stablest carbene ion and therefore will be formed with utmost tendency, and that proton is going to be released with utmost tendency and will be most acidic in nature. So D is the superior. After D, now you have to compare. If you compare, you find that A, the option A had resonating structures. I had drawn, it had 4 resonating structures. If you can see, the 4 resonating structures where minus was delocalizing. Once you draw B, you have seen 3 resonating structures. You can see with B you had 3 resonating structures. And C, there were no resonating structures. When I am saying resonating structures, you should remember I am focused with delocalization of negative charge. So here there were 0 structures. I mean only 0 means none other form. This is the only one. This is the only one. Now if you compare these from your ignorance, you may say that 4 resonating structure is a better option than 3. I am saying with a clause that in ignorance you will predict that 4 is a better option than 3. But you have missed one point. Although the quantity is more, but in these 3 resonating structure, the stablest I have drawn has got a better quality, far better quality than any of the 4 resonating structures belonging to A. And although the B had less number of resonating structures, 3, A had 4, but you understand, although in quantity it is missing, but it is not missing by a huge value. The A was 4, B is 3. But the matter of fact is, the thing is this, the B has a very stable, the best stable resonating structure. Why I am saying this? Because it has the negative charge on the more electronegative element oxygen. You should understand any resonating structure which has minus charge on more stable, more electronegative element is a better structure. So that is what I want to say. Since it has minus charge on oxygen, its quality is far better. And because of that, the B is a better option than A. So whenever there is a tussle between, there is a fight between quality and quantity not differing much, like here, one is 4, one is 3, but quality, if it wins, you should go with the quality, and that is what is happening in this case. After D will come B, and then A, obviously A. And if you come to C, the C is the last position. And why it is last position? As you all know, the negative charge was remaining localized on that carbon. It was not delocalized, it was not shared, and the negative charge, as you all know, is a burden. and that has to be shared for the stability to increase. So that is how you should see a problem. You should make the conjugate base, you should make the carbene ion for the acidity to be seen, to be checked, and then you should watch for their stability by resonating structures they form. Then you should keep in your mind, not always quantity is a winner. Quality may change the order, and has happened in our present case. Although B had 3 number, A had 4, but B had a better quality resonating structure than A. Okay, for an example, if you have 4 friends, you have 3, and another person has got 3 friends, but the 3 friends he has, one is very powerful, very dedicated, and the 4 friends the other has, these 4 are casual, they are not much bothered about you. Then which is a better situation? The one where you although had less number of friends, but the strength of friends were high, the quality of friendship was higher. So that is how you have to see the things as.